Assalamu alaikum. So in this video, using this Fourier series equation, we will find the equation of a square wave. Let's say it is f of t, which is a function of t, and the square wave looks like this. It's a periodic signal where the signal is, the value is a for the time t1 and the total time period is t. That means this time is 0, this time is t1, and this time is simply is equal to t. So we have to find the equation. So this is the equation of f, where we have to find a naught by using this equation, similarly an and bn by using this equation. So let's start. So first let's try to find a naught. So a naught is equal to 2 divided by t. Then this symbol means you have to do an integration over one period. That means you have to do an integration from 0 to t, and that is one period, right? Okay, but look carefully that from 0 to t1 our signal's value is a, but from t1 to t, from t1 to t, I mean in this region, the signal's value is 0. That means this term will be simply is equal to 0. So we have to integrate only the first term. So if I integrate the first term, I will get a t1. So a naught is equal to 2a t1 divided by t. Okay, now let's talk about the second equation, second coefficient an, which is equal to 2 divided by t. Again we have to integrate over one period, f of t cos n 2 pi divided by t dt. Again you have to integrate from 0 to t, and our square wave looked like this. From 0 to t1, as its value is a, so let's take from 0 to t. From 0 to t1 the signal's value is a, but from t1 to t the signal's value is 0. So this term will be simply equal to 0. So we just have to integrate the first term. Okay, so 2 divided by t, let's take the constant outside, and if you integrate cos, you will get sine. So sine n 2 pi divided by t. At the denominator you have to write the coefficient of small t here, and we have done integration from 0 to t1. So an is equal to t cancels out, 2 and 2 cancels out, so a divided by n pi. Then we have to put this t1 here, so we will get sine n 2 pi divided by t into t1. Then we have to put 0 here, that means sine 0 it is, so sine 0 degree is 0. So an is equal to a divided by n pi sine n 2 pi divided by t into t1. So this is the value for an, which is simply dependent on n, the nth harmonics. Okay, now we have to work with bn, which is equal to 2 divided by t, integration over one period, f of t sine n 2 pi divided by t dt. So we have to integrate from 0 to t. Okay, so again we have to integrate from 0 to t1. The signal's value is a, but from t1 to t, the second part, the signal's value is 0. so this part will be equal to 0. So we have to work with the first part. Take this constant a outside, and if I integrate sine, I will get minus cos. And at the denominator we have to write the coefficient of small t, and we have done integration from 0 to t1. Okay, so t cancels out, 2 cancels out, then minus a divided by n pi. Now let's take t1 here, then we will get cos n 2 pi t1, then we have a minus here, then if you put 0 here you will get 1, because cos 0 degree is simply is equal to 1. So this is equal to 1. So now put this minus, multiply minus 1 with the thing inside bracket, so you will get 1 minus cos n 2 pi by t into t1, and here you have to write a divided by n pi. Okay, so you have get all the thing, and now if you put all the values here, you see you have find a naught, then an, then bn. So put all the values here and you will get the series of square wave. Okay, so thank you.